Okay, this is yeah. This is tutorial for boundary layer number 6. Figure shows a uniform flow past a flat plate. Determine the wall shear stress TW, tau W between AD equals 0.5. So AD equal 0.5 mean the distance from A to D. So and then the velocity profile is laminar, U over U, Y over delta, to the power of 1 over 2, delta AB. So delta AB equals 0.5 means that for section AB here, the delta is 0.5. So what is the meaning of this? So we know that delta is boundary layer thickness. So means that thickness at here is 0.15. So and then delta ACD. So maybe this is some typo. So it should be delta CD only. So means that the delta at cross section CD here is 0.56. So means that the delta here is 0.16. Okay, take the density is this one and the mu is this one. Okay, so and then what we need to do is we need to determine the wall shear stress. Okay, between AD. So means that previously in our theoretical, we calculate the velocity, the shear stress may be for the whole plate. But for this question, they ask to calculate what is the shear stress only for this area. So we still can solve this one. So we could do like this. Okay, so this is the information that we get, and then from the question we know that the velocity profile is y over delta to the power of 1 over 2. So let's say I solve this by using the idea of eta, because previously there are no question about eta. Okay, and then you could do this again by using the idea of u over u by using this velocity profile. It's still okay. And this is the information that we could extract from the diagram. So means that the delta AB is 0.15, delta CD is 0.16, and then we could write like this: D delta is equal delta CD minus delta AB. So it is equal 0.16 minus 0.15, so it will become 0.01 meter. So means, and then the changes of x, so we could write dx equals 0.05 meter. So this is actually to test the understanding of student understanding about the equation and what you could extract, how to get more data from the diagram, how to get more data, or how to get data to fit with your equation. Okay, we'll see this later. So and then okay, so the question is, what is the value of tau at wall? Tau wall here. So we could say that we could solve shear stress by using von Karman equation here, and then we substitute the value of velocity profile. Okay, and then we could get this. So and then finally we could simplify this one into this term. Okay, so here it's actually, if you don't want to make an integral work here, so you could find the value of theta first. So find what is the value of theta. So and then you substitute into these terms. Okay, so this is the value. Okay, you substitute, you integrate with 0 to delta. Okay, you will get this one, and then you will get tau is equal to rho u square d delta over dx with 1 over 6. Okay, the problem is, okay, we cannot continue the calculation because the idea, okay, previously in our theoretical, we are calculating the whole plate. Means we equalize with Newton law of viscosity and so on and so forth. But the idea is we calculate from 0 to the end of the plate. But this question is actually only calculate for certain area. So the simple one is we could substitute this equation actually by manipulating the meaning of the equation. So how to manipulate it? So we will have, okay, we found that rho is a value. We could get value for rho. We could value for u here. 1/6 is also a constant. So the problem is what is d delta and what is dx. Okay, I think you already know. So the meaning of d delta means the changes in delta terms. So and dx here means the changes of the changes in x direction. So as we calculate here, so d delta is actually the difference of these two values. So it is equal to 0.01, and the dx here is actually the difference or the difference at y axis here. So by understanding the meaning of d delta and dx, okay, so we could solve this problem by substituting 0.01 as d delta and 0.5 in dx. Then you could estimate the value of shear stress here is equal to 1 times 0.007 times 10 to the power of -3. Again, please make sure that you write the unit. So the unit is Newton per meter square. So for this, so this is the answer for this